Okay, so we're going to pick up from where we left off. But are there any questions before we begin? Okay, so last time we left off, we were talking about files, right? And we said that there were three types of file objects. There's the IF stream, the OF stream, and the F stream. IF streams are for reading, OF streams are for writing, F streams are for if you want to do reading or writing. Make sure you use the appropriate one for the appropriate situation. If you're only planning on reading, use an IF stream. Only planning on writing, use an OF stream. If you need to do both to that file for whatever reason, use the F stream. So there are a couple of constructors that you can call. So you can just say F stream and not provide any arguments when you create the file stream, and that will create a file stream that's not associated with any file. You can also, when you create your file stream, you can specify a name, and it will go, that name should be the path to the file that you want to open, and you will also automatically open that file. And then there's F stream, and you can say some file name and mode, and this will open it up in a different mode besides its default. The modes are in the next slide, but you can combine the modes together by putting a pipe between them. So anywhere, these all just say F stream, but they also work for IF streams and OF streams as well. So here we're creating a file stream that's just some file. We don't know, this F stream is not associated with any file yet, so you couldn't read from it or write to it at the moment. You actually haven't opened the file. Here we're going to create an IF stream called reader, and then we passed it the path to the file that we wanted to open up. So it'll create this end file stream as well as open up that file. And then here you can see an OF stream and the path to whatever file that I was planning on writing to. And then I did two other things over here. I did out so that I could write, and then I also did append so that all my writes would go to the end of the file. Any questions here? So here are your modes. So there's app, which stands for append, which means all of your writes that you do to that file will go to the end of the file. There's 8. 8 stands for at end. This will set you to the end of the file, but later on, when you do movements through the file, which you could use like by doing fseek, you can go to a different position. Whereas if you do append, all your writes will always go to the end of the file, regardless of whether the read-write head is at. Binary is to consider the stream as being binary rather than text. In means you want to read from it. Out means that you're planning on writing to it. If you only specify out, trunk will automatically be added in as well. So if you don't do in or app along with out, trunk is automatically specified, and trunk will erase the contents of that file. Any questions here on the modes? So opening and closing a file, if your stream is not associated with a file, you can do .open, the path to that file, and then it will go and open up that file. If you already have a file open, this command will fail. Close will close the file associated with that stream. You can't read from it or write to it afterwards anymore. But you don't really generally need to do this, because whenever the stream gets destroyed, if it happens to have a file open, it will automatically close it for you. So there's just open and close. Nothing too interesting there. So streams, or the file streams, are just streams. So everything that you've seen that works with cin and cout also works with files. So if you wanted to do some formatted read, you can use like the double arrow operator. If you wanted to do some formatted write, the other double arrow operator. If you wanted to do a get line, use get line. If you just want to get a single character, regardless of whether it's white space or not, get. So yeah. So here would be like print next int. So notice that this takes in an iStream reference, which is like the base class. So I could pass into this function either like cin, or this should not be. This would pass in whatever stream that I wanted to read from. So I could pass in either an in-file stream, an F stream, a string stream, cin. All would work here on this one function. But you have to make sure that you pass in a reference. So I attempt to read in an integer from this stream, and then I write it to standard out. So here, if I had an IF stream, some file, I could pass that to my function, not path the file. Or I could pass in cin, and both will work. So if you want to make your functions a little bit more general, right, you can use iStreams or OStreams, and they'll work with both files as well as the standard output. If you specifically needed a file, right, you'd have to use like an OF stream or an IF stream. Any questions here? So some other ways that you can read, you can do your stream.get, like it's the next character, get line, some stream, some string, you'll get the next line out of it. If you want to know if you've reached the end of the file, you can check to see if the stream is still good. There are some more exact checks that you can do. So you can do stream.good, which means there have been no errors so far, which means it's safe to read from the stream. Stream.bad means the stream is not okay to read or write from. Something happened in the past that makes it that this stream is probably not recoverable. You probably can't read from it or write to it again. End of file will return true if you've gone past the end of the file, and fail will tell you if you failed to read the last thing that you tried to read. For example, if you tried to read in an integer, but the user entered in Bob, right, you would fail to read in the integer because the integer was expecting numbers and you wouldn't read anything. So pretty much when you're doing like your reads from your files, they're all going to look like this. You attempt to read in whatever it is you're trying to read while the stream is still good. So if this read failed, you don't want to keep doing things, you probably want to stop. This probably most likely means if the input isn't bad, that you've reached the end of the file. You do something with whatever it is that you're planning on working with, and then you get the next thing. Yeah. So with getLine, there is the option to provide a third argument to it, which is the delimiter to search for. So you could say getLine, but you have to it only accepts exactly one character. So you could do new line or space or tab, but you couldn't do like all three where it stopped on any white space character. Does that make sense? I'd have to go double check getLine, but if your goal is just to read in a sequence of non-white space characters skipping over white space, read it into a string. The string automatically does that. So if you just read it into a string and you don't use getLine, you'll get the next sequence of non-white space characters from the stream, the next word. Right? So you don't need to do something as complicated as what you're attempting to do. Any other questions? It's really important that you structure your reads from files like this, because if you try to use the input before you check to see that it was good, you'll end up doing like one iteration too many, and you'll end up doing something with something that doesn't, you'll end up doing the body of the loop with something that doesn't exist. So make sure it's a read while the stream is still good, do something with it, get the next thing. If you try to write it any other way, it's not going to work correctly all the time. So be careful with that. Yeah. So like if the type of variable over here was string, right, you would read the next sequence of non-white space characters from the string, which you know would be the next word. So if the type of variable over here was string, you would read the next word from the string. So it depends, because again, the type of the variable here could be different. Maybe your file is made up of integers, right, or some numbers. Then if the type of the variable was int, right, you'd keep reading the next int out of your stream. If the type of the variable was a double, you'd keep reading the next double, or the next double that you'd encounter in the stream. Right? So the formatted read is going to be dependent on the type of the variable on the right-hand side, what actually gets read. If you just want entire lines, you can use like getLine. Or if you just want a character including white space, it would be get. Generally, you probably won't need to use them, but you'll see some examples in a couple of minutes. So the final thing is that streams aren't copyable. This includes OF streams, F streams, IF streams. So if you want to pass a stream to a function, you have to make sure that you pass a reference to that stream. You're passing the original because you can't pass copies of them. Does that make sense? So you can't do something, like stream1 equals stream2, because that would attempt to copy stream2 into stream1, which no copying exists. And so you get an error there that this function doesn't exist for copying. Does that make sense? So here's an example of a function that copies a file to another file. Right? So it opens up that file and creates a copy of it at the specified destination. Does that make sense? So what do you think you'd have to do inside this function to make it work? So with the source file name, do you want to read from it, write to it, or do both? Read. So what should you use to open it? IF stream, right? An in file stream. The destination, do we want to read from it, write to it, or do both? Write to it. So what should we open it with? OF stream, right? So we open them both. And after we have both these files open, what should we do? Keep reading characters from the first file until there are no more, and copy them into the second file. So over here, I have it where, like we said, we made a in file stream and an O file stream, and then I called copy, which is basically going to do what we said before, but I have it more generalized as copying one stream to another stream. And notice again, these are references because you can't put copies in. So what I do is I get the first character while the stream is still good, write that character to the destination, and then get the next character. Because I want to copy white space over as well. Right? That's why I'm using get. If I just read it into cur-char, the problem would be that I wouldn't have any of the white space that appeared in the original. I just have all the non-white space characters. Does that make sense? So over here in main, I accept the arguments as command lines. So argv1 is the source file, argv2 is the destination file. And again, you can set them by going into edit configurations. And so I said /sample file to /awesomefile.txt. By default, when you run your program, it's not running in this directory, file examples. It's actually running inside this directory, cmake build debug. So from this directory, right, I want to get to samplefile.txt, which is one level above. So /samplefile.txt. In general, if you're working with files, it's just easiest to specify the absolute path. But if your absolute path has white space in it, make sure to enclose the path in quotation marks. So here's sample file. It's like, this file is really cool. Has lots of nice stuff in it. And then if we go ahead and we run our program, hey, great, I have a new file that has the exact same stuff in it. Do you guys have any questions about files? Yes. The main? So you can think about argv, it's an array of strings. So argv1 is the first command line argument, and argv2 is the second command line argument if we don't count the name of the program. So remember, we ran this with two things, samplefile.txt and awesomefile.txt. argv1 is this guy. argv2 is this guy. Dot slash means one level above. But again, like remember when you index arrays or you index lists or index vectors, you can use the square brackets to index them. Yeah. There's a lot. So we will definitely get into what a char star star is a little bit later on, but that involves pointers and involves a lot more of like the C end of things. So we'll hold off for right now. But for right now, just consider the char star star argv to be an array of strings. Technically, an array of C strings, which are slightly different than C++ strings. But we will cover it later on in the class, I promise. Anything else? Is there anything else that you want to see happening to files? Can we do what? Output them to the screen? So if I wanted to output them to the screen, what I'd have to do is, won't quite work out, but what I could do is this. I could ask for an std : if stream in argv1. And then because my function over here that I wrote accepts iStreams, what I could do is now include IOStream and then say copy in to std : cout. Oh, okay. Okay, that was the problem right there. I forgot to include fstream. So now, instead of writing them to the file, I'll write them to the screen.
It's writing both to the file.
So right now, this one said to copy argv1 to argv2, so it's copying it to awesomefile.txt. This guy over here said copy the first argument to cout, to the screen. So again, because I had my function back here, except just O streams and I streams, is able to work with both cin as well as, or cout as well as files. Any other questions? Yeah. How do you get to the the second to last line of the file. There's like not necessarily like any good way of doing it. What you'd have to do is read all the lines of the files up until the end, potentially maybe storing them into a vector, and then once you've read them all, like each line into a vector, into that vector of strings, then you get the second to last one. You could do a little bit more efficient than that by just keeping like the last 2 lines you've seen, and that would let you get the second to last line. But yeah.
Well, what was the problem?
Oh, the problem that I had before was I forgot to include fstream. That was it. That's why I was getting the error here about I didn't know what infile was. Anything else with files that you're interested in? Yeah. But files examples doesn't actually have the fstream library defined inside of it because I don't make a reference to an fstream inside the .h, right? Only the CPP had the fstream included. Yes. So your question is like, what does the fstream file have in it? The fstream file has the definitions for ofstream, ifstream, and fstream. So the types of file streams. Which, since I was now referencing that back here in main, I needed that type of an ifstream, which is included inside here. Anything else? So any file that you want to use that header in, or you want to use a member element in, so any file I want to use an ofstream, ifstream, or fstream in, I have to include fstream. Otherwise, it won't work. Okay. So the next thing that we're going to talk about is input validation. Streams are not strings. They're different. A stream is a representation of a sequence of characters. It doesn't necessarily have to come from a string. So if you want to do IO validation here in C++, make sure that what you've gotten is what you expected to get. Here's your steps. Assuming that the input that you're receiving is line-based. If it's not line-based, you might need to do some small changes to this. But if it is, like most keyboard input is, this will work. So first thing you do is you read an entire line using getLine. You then place that line into a string stream. A string stream is another type of stream, but it's a stream over a sequence of characters, or it's a stream over a string. So you'll see examples of that in 1 second. Then for each value that's supposed to be in that line, read it from the string stream and check to see if that read was successful by doing if string stream. If it was, great, you're good to go, right? And that the input that you received is what you expected. It was formatted correctly. But if the if statement doesn't hold true, it means the input that you got was bad, it wasn't formatted correctly, and so you should probably stop reading and give some complaints. Then after you've read everything that you've expected to read in, then check to see that the only thing that comes after is white space. So I have 2 functions over here. One that's going to get a valid integer from the stream. One gets a valid double. And these 2 functions are both expecting that the user just enters a single number on the line. The first one an integer, the second one a double. I'm going to read it from some stream in, and then I'm going to write my prompt over here to some output stream. Most likely going to be C in or C out over here. So if we're following that pattern from the previous slide, the first thing that I do is I assume that the input is going to be false. Right? It's not validly formatted. It's not formatted correctly. Then I need to attempt to get the input. So I put the prompt out to the screen for the user to see, right? Hey, enter whatever you're supposed to enter. Then I get that line of input that they did indeed enter. And I take that line that I got and I throw it into the string stream. This will allow me to do the formatted reads out of it, do the conversions to the appropriate type. So then I attempt to read input into number. And if this succeeded, just saying like if input or just saying input and some other Boolean operations will cause it to return true. So for the input to be valid, I had to have read successfully. That's the only way that input's going to be true. And the other stuff that's contained inside the stream is only white space. And I want to keep doing this while the input is not valid. Once they finally enter in valid input, I'll have this function return it. Any questions here? So again, we ask for the input, we get the entire line. We then attempt to parse the input, which is in some ways these two lines. And then if we were able to actually read something and the only stuff that's left is white space, we're good. If it's not good, keep asking. So the user might enter something like 35 space enter, right? That should still be considered good input. But if the user enters in something like 35 space dogs, right? I don't want that to be considered valid input because I only wanted the user to enter in a number. So I will be able to read something because I'll be able to get the 35. So this part would be true, right? But I don't want there to be the dogs afterwards. So I check that the only thing that comes afterwards is white space. Does that make sense? I will show you the difference in removing this line, what it does, and then adding it back in. While the input's not valid. Well, like, so if the input is true, right? Not true is false, so you'd stop. So if the enter in good input, we'll stop reading. For the double, the piece of code is exactly the same. The only thing that I've changed is instead of having this be an integer, it's now a double. And if you wanted to read in a string and only have the user enter in one string on a line, you would do the exact same code, except you'd change the type from double to string, and you'd be good to go. Here's that this stream contains only these values. So what I do is for each character in the stream, if it does not appear in the set of valid values, return false. Then get the next character. If we get through all the characters in the stream, return true. Yes, we will talk about that right now, and this is a good motivating example for templating, which allows you to do code that's type agnostic. You don't care about what it is. So now if we go and run our code, it just says, it asks us to enter in an integer, then enter in a number, then enter in a double. So if we go ahead and run this, and we enter in like lots of bad things, like Bob or cat 58, that's not going to work, or right, all these things fail. If I can do like space 56 space tab space enter, that's good, right? So a number followed by any amount of white space, and for a double we'd get the exact same behavior, right? Like that's gonna fail. 45.37 whatever, that fails. 45 point should succeed. You entered in 45. We cool here? Yeah. So for right now, I've said like if the user enters in something like this, I said that's not good. You just have to give me a single number on this line. That's the only thing I'm willing to accept. Now, we talked about that this piece of code right here, this AND condition is what allows us to make sure that there's nothing else that comes afterwards. So if I do this and put a semicolon here, and we cast it to a bool now because it doesn't know to do the boolean, the boolean doesn't know to turn it into a bool at the moment. So now if I do things like you know, 56 min, that's gonna be okay now. So if I enter in 0, so if I just enter in 0, that's it. That's fine, right? But that piece of code that was there afterwards was to make sure that the only thing that came after the number was white space. No, because we were able to read an integer. 0 is an integer. Right? But now, if I do something like, that's going to fail. But now the question is, if I enter in like 56.58, that's going to succeed. And now let's say I enter in 100 here. Well, I got 100 because I read the entire line. But I probably shouldn't succeed on 56.58. If I go back and I throw in the line of code that I took out, and for an integer, and I try to enter in 56.58, it won't work anymore. Because what's going to happen is we'll be able to read the integer portion, the 56, and then what will be left is the 0.58. 0.58 isn't only white space, so we'd say, oh, there was something else that came afterwards. We didn't want anything else to come afterwards, so the read would fail. Are there any other questions here about input validation? So you should totally be able to do that now as part of your rock, paper, scissors. If you have a set of strings that you're willing to accept only, after you read in that string, you could just check to see if it's one of the good ones. Right? Check to see if it appears in your set of valid input. So we'll take a brief detour before we get to random numbers, and we'll talk about templating. Because we saw before that the code that we wanted to write was identical, but the only thing that was changing was the type, right? If we look back here between getValidInt and getValidDouble, the only thing that's different is the types here. This is double, this is int. This is int. No, switching to auto won't work. This is double. Right? Or imagine we wanted to write a min function, right, for integers. It would look like this, right? Take an a and b. If a is less than b, return a. Otherwise, return b. Well, let's say we want to now write a min function for doubles. Oh, hey, the code's the same, except this is double instead of an integer. Well, now let's say, well, we wanted to write one for strings. Oh, great. Now we have one for strings. And now let's say we want one for, like, type A, B, C, D, E, F, G, H, I, J, right? We want to write like a min function for every single type. We're going to be here all day, right? There's an infinite number of potential types because you're allowed to create more types later on, which you'll see hopefully next week. So what we'd really like is to be able to write some function that just takes in some type, say t, right? And it would work for any piece of code, right? And so I wouldn't have to keep rewriting this function for every type of thing that I wanted to take the min of. So this is possible in C++. And if you want to do so, you create what's called a templated function. The syntax for creating a templated function is template in lowercase, type name, the first templated type, comma, type name, the second templated type, comma, every single type that this type is templated over, right? Each of those different types that you want to have in as like stand-ins for types in the future. If there's only a single type, the convention is to use t, for t is some type, just like when you do loops like I and j are very common for indexing. So over here we'd say template type name t, and t is the stand-in for my type. So t in the future might be string or int or double or type X, whatever it happens to be. So we're going to take in a T, or take in a T reference and another T reference, and we'll end up returning a T at the end of the day, whatever T happens to be for the particular time we call this function. Any questions here before we keep going? Yeah. Yes, you can also template classes, and we'll talk about that later, how to do so. So auto means compiler, please try to figure out what this type is, right? But the compiler has to be able to deduce the type, right? That's why you can't just say like auto X, because the compiler is like, what the heck is X's type going to be? It has to figure it out from the right-hand side. So here, T, for templating, you're going to say, I'm going to have a stand-in for some type. Not compiler figure out for me what it's supposed to be. T is going to be like a type placeholder. So that means that this variable T is a type. If you look online for like any examples on this, it's very common to see instead of type name class here. So you'd see template class T. I like using type name instead because it's a lot more explicit of the fact that T is a name of a type. But if you want to use class, completely legal.
The template,
you can't just say template T here. You have to say that T is the name of a type. So some details about templated code is that all templated code has to appear in header files. It shouldn't show up in your CPP files. This is because how C++ handles the code. What it actually does is it doesn't create a single function for all min. What it does is it uses this as a template to create different types of min functions depending on the type of T. So what will happen is if T happens to be an integer, we'll go create a min function where we substitute in for T int, and we'll end up with this. But if T's type happens to be double, we'll create another function that looks like this, where we replace all T's with double. Or if T happened to be string, we'll replace all of our T's with string. Right? So we create many different functions, but we'll only create the ones that we actually need. And so the compiler needs the templated definition to know actually how to write the code, because the compiler writes code for you when you're doing the template. So if we did something like min35, again, T would be replaced by int, and so you'd get a integer version of min. If we called it with two strings, you'd get a string version of min. So most of the time, the compiler can figure out what the type of our template parameter is supposed to be based on the arguments that you pass in. But sometimes it's either too difficult for the compiler to be able to do it or just impossible. So you're going to have to tell the compiler, what do you mean to be that type? And the way that you do that is after you write the function name, you do triangular brackets, and you enclose the type inside those triangular brackets. Sorry. This is like what you've already seen with vectors and maps, right? You have to say, well, I want a vector of integers. I want a vector of doubles. I want a vector of string, right? You have to say what type of vector you want. So if the compiler couldn't figure out what you wanted the min of, so you could say, well, I want the min of string. So T was always, T is being explicitly set to be string, and you'll have to have the compiler figure that out for you. Or here you could say min double, right? And so this is going to do the double version of min. And this one will do the integer version of min. So if the compiler can't figure it out for you, it complains about like, I'm not sure what this function is, give it the type inside the brackets. Yeah. Get to that 1 second. So when you specify the template parameters, you can list multiple types, right? So you could say template T1 or type name T1, comma type name T2, comma type name T3, comma type name T4, right? However many different types that you need placeholders for, you can just list them out. You can also provide default values for some of these types. Maybe by default, if the user doesn't provide this type, I want it to be an integer, or I want it to be a double, or I want it to be a string. You can say that type equals the default type. And so over here, what I'm writing is a min function that can take two different types, right? A T1 and a T2. But if the user doesn't provide a T2, it will default to being the T1. And so now we could have it where we take the min of two different types, assuming that those two different types were comparable, right? If you're not able to say type 1 less than type 2, this code will fail to compile, right? For example, if you try to say, like, is an integer less than a string, there is no less than that compares integers and strings, and so it would fail. But you could have this do like a min between like ints and doubles now, or a double and an integer. Those comparisons do exist. We're also assuming that the second type, when we returned, it's convertible into a T1. They have to return something consistent at the end of the day, and I don't know whether I want to return a T1 or a T2, so I'm always going to end up returning T1s, and so we assume that T2s are convertible into T1s. No, the type name here can either be type name or class. One of the two. It can also be an explicit type, like int or string or double. Yeah, type name is a reserved keyword. Any other questions? Yes, if you want this to be like any arbitrary type, say type name. Sometimes when we're writing our templated code, there might be a particular type where you either want to do something different for that explicit type, or that we could solve the problem in an easier way for that type, because it's somehow special. It's a little bit different than just a generic type. If you want to do this, when you declare your template, you say template and then triangular brackets, right? I'm not actually going to be templated over a type, and then we make our types here. Instead of listing out T's, we have the actual type that we're trying to do. So integers here. So if the user now ever tries to do the min of two integers, it's going to use this special min function for integers, which prints out I'm a special case, and then just like A less than B. If that's true, return A, otherwise B. Not necessarily a particular great example here of using specialization. And whenever, for this class, I don't think you'd ever want to specialize any of your templates, but I want to point it out that it does indeed exist. So if you needed to do something different for this type, you would specialize the template for that type. Yeah. It's the ternary operator. So what we do is we check, is A less than B? If that's true, this expression will result in A. If it's not true, the entire expression results in B. So it's kind of like, if A is less than B, A. Otherwise, B. You just asked that question. So again, it's the ternary operator. It basically evaluates if A is less than B, right? The expression evaluates to A. Otherwise, the expression evaluates to B. Some final notes. Again, templating is for when you want to create functions where the code that you want to do is identical except for type. And the only thing that changes in that code is the type. That's when you're going to reach for templating to solve a problem. Most of the code that you write in this class will not be templated because your code is going to be dependent on some particular type. If you do mess up when you're doing templating, the compiler has some really nasty error messages for you. They're really hard to figure out what it's saying without a lot of investigation into it and a lot of very careful reading. So be forewarned if you do reach for templates that you might have to do quite a bit of work writing them to make sure that they're syntactically correct and actually compilable. If there are mistakes, they're very hard to understand. But read through them, and if you still don't understand what it means, come to office hours. Again, templated code must always appear in header files. It doesn't get compiled directly. And then, again, templated code will only be instantiated if it is called and only for the types it's called on. So before we had this min function. if you only call min on integers, only one function will be created, a min function for ints. Right? If you do a min function for integers and a min function for strings, now there will be two separate ones, one for integers, one for strings. But we're not going to generate like every single possible type, only the ones that you actually asked for. But if you never use that templated code, the compiler is actually never going to run it, so it can be like easy to hide mistakes inside there. Also, CLion isn't as good at finding mistakes in templated code as it is in normal code, because a lot of times the errors depend exactly on what the type t is. For example, if you have you call the .foo method on your variable of type t, if .foo doesn't exist for that type, then you'll get an error when the attempt gets to be compiled for that type. But CLion can't know ahead of time that the particular type that you're going to call it on actually doesn't have a .foo or does have a .foo. It can't check it because it's for some arbitrary unknown type. So we just kind of assume that it exists until we compile. And if we compile and it does exist, great, code compiles. Compile it doesn't exist, errors. Very, very hard errors. So let's see some examples of this. So over here, I have my declarations for my functions. So here we've declared our min function that you saw they're working with in class. So we return a t, and we find the min of two const t references. Here is our special template, our specialization for a min of integers. Here we also are going to do swap. So we're going to swap two values, a and b. Here we're going to sort a vector of type t. So some vector of types who I don't know what they are. I also have the ability to find the minimum of the minimum value between a range of two iterators. And then I'm also going to check to see if some container contains some value. And notice over here I have two templated types, the container type and the value type. So here are my definitions. Again, they are all in the same .h file because they can't be in the .cpps. So here is min. So if a is less than b, return a, otherwise return b. Any questions on min? So here's swapping. So what we do is we create a temporary who has the value of a, then we make a equal to b, and then b equals 10. So the really important thing to catch here is that we have t references, right? If this was just t's, would this work? No, and if we just had t's here, why would it not work? Because we'd be accepting copies of the values that we passed in. We'd be switching the two copies, then our function would end, and what happened to the originals? They're still the same. We only changed the copies. Does that make sense? So here is my sorting of a vector. So what I do is I get an iterator to the beginning, and I go all the way through the end, right? I attempt to find the iterator that's pointing to the smallest value, and then I make it swap with the position that I'm currently at. So I swap those two values, right? Have you guys seen this type of sort? Where the first thing that you do is you find the first smallest number in the array of numbers, and you put it at the first position. Then you find the second smallest number, and you put it at the second position. Then you find the third smallest number, and you put it at the third position until you've gone through all the numbers. The way that this is working over here is, remember, like iterator at the beginning is pointing to position 0, right? And so we're going to try to find the smallest value from position 0, the first element, all the way to the end. So we'll find the smallest of all the values, and we'll make sure that that ends up in the first position, right? Then iterator is going to advance to the second element, right? So the first element already has the smallest number. So now I'm going to find the smallest number from the second position on down and put it into the second position. So we'll talk about this afternoon, this evening, because we're out of time, unfortunately. And then we'll get to random numbers tonight as well.